Imagine looking up at the night sky. What do you see? You see stars. Countless pinpricks of light scattered across a vast, dark canvas. For most of human history, that is all they were to us. Points of light. But now we know better. We know that many of those stars are not alone. They are suns, just like our own. And orbiting those suns are planets. Worlds with their own stories, their own histories, their own unique place in the cosmos. Our galaxy, the Milky Way, is teeming with them. There are likely more planets than there are stars. We have found giants made of gas larger than Jupiter. We have found icy worlds, far from their stars' warmth. We have found rocky planets, a bit like our own Earth. The variety is simply breathtaking. But among this incredible cosmic menagerie, some planets stand out. They are truly extreme. These are not the familiar, slow-moving worlds we see in our own solar system. They are the sprinters of the cosmos, moving at speeds that defy our everyday intuition. This is the strange reality for a special class of worlds known as ultra-short period planets. What exactly is an ultra-short period planet? Scientists classify a planet as an ultra-short period, or USP world, if its orbital period, its year, is less than 24 hours, less than one Earth day. To put this into perspective, think about our planet, Earth. We orbit the Sun at a comfortable distance of about 150 million kilometers. It takes us 365 days to complete one full circle. Now picture a planet that completes that same journey in under 24 hours. To do that, it must be incredibly close to its star. Often, the distance is less than 1/50th of the distance between the Earth and the Sun. They are practically skimming the surface of their host star, moving at hundreds of kilometers every second. The discovery of these worlds was a complete surprise. Our theories of how planets form suggested that they should not exist so close to their stars. So when astronomers first started finding these cosmic sprinters, it sent ripples through the scientific community. It meant that our models were incomplete. The universe was showing us that it had more tricks up its sleeve. What exactly are these remarkable worlds? Imagine an Earth, or maybe a slightly larger version, stripped bare and placed next to a roaring furnace. The side of the planet that faces its sun is permanently superheated. In contrast, the night side, the hemisphere that perpetually faces away from the star, could be a very different story. While the day side boils, the night side could be cold enough for rocks to remain solid. One of the most profound features of an ultra-short period planet is its rotation. These worlds are what we call tidally locked. The immense gravitational pull of the host star has slowed the planet's spin over billions of years. This creates a permanent, unchanging division between a world of fire and a world of ice. Between the searing day side and the frozen night side lies a region of perpetual twilight. So how did we find these impossible worlds? We did not see them directly. Instead, astronomers had to be clever. One of the most successful methods is called the transit method. It does not look for the planet's light, but for its shadow. Space telescopes like NASA's Kepler and its successor TESS are masters of this technique. It was Kepler that first revealed just how common ultra-short period planets really are. To study these distant worlds, we need powerful tools. Today, we've built colossal observatories in some of the most remote, pristine places on our planet. These are the giants of the ground. One of the key techniques these telescopes use is called radial velocity. By measuring this subtle wobble, astronomers can determine the planet's mass. When we combine this with the planet's size, we can calculate the planet's density. To get the sharpest possible view, we need to go above the atmosphere. Space telescopes have revolutionized astronomy, and they have been absolutely critical in the discovery and study of ultra-short period planets. With telescopes like the James Webb Space Telescope, we can analyze the starlight that passes through a planet's atmosphere during a transit. This technique allows us to measure the temperature of the planet's dayside directly. To answer what these worlds are actually like, scientists must squeeze every last drop of information from the star's light. They use a technique called spectroscopy, splitting the starlight into its constituent colors, like a rainbow. By subtracting the behind measurement from the beside measurement, we can isolate the light coming from the planet alone. This is an incredibly difficult measurement, but it is now possible. Let us try to imagine what it might be like to stand on the surface of an ultra-short period planet. The sky above would be dominated by a colossal, searing star. The ground beneath our feet would not be solid. We are standing on a global ocean of magma. Now, let's travel to the opposite side of the planet, the frozen night side. The sky would be one of absolute, unending blackness, punctuated only by the pinpricks of distant, unfamiliar stars. Between the searing day side and the frozen night side lies a region of perpetual twilight. This is the Terminator line. This Terminator zone would be a place of incredible violence with winds of unimaginable speed. These winds would pick up dust and vaporized rock, creating perpetual, planet-girdling storms. It would not be a gentle twilight, but a chaotic, wind-swept battleground. When we talk about alien worlds, the question of life is never far from our minds. Based on everything we know about biology, the answer for life as we know it is a resounding no. The conditions are simply far too hostile. But this does not make them any less valuable. They show us the incredible diversity of worlds the universe can create and remind us that not every planet is destined for blue skies and tranquil oceans. The discovery of ultra-short period planets has had a profound impact on our understanding of how planetary systems are built. By studying these scorched survivors, we can piece together the dramatic history of their systems. The neat, orderly model we derived from our own cosmic backyard is just one possible outcome of a complex and messy process. Perhaps it is the systems like ours that are the unusual ones. The ultimate goal for many astronomers is to find another Earth. The discovery of ultra-short period planets has a surprisingly direct impact on this search. Finding a USP can act as a signpost, pointing us towards systems that are rich in small, rocky planets. Furthermore, because many USPs are found around small, cool red dwarf stars, they guide our search for Earth-like worlds towards these types of stars. The USPs are, in a way, accidental pioneers in our quest for life. These planets are more than just astronomical curiosities. They are cosmic laboratories pushing physics to its absolute limits. On their surfaces, rock behaves like water, and atmospheres are forged from vaporized minerals. For all that we have learned, the story of ultra-short period planets is still filled with profound mysteries. Chief among them is the puzzle of their survival. What stops them from continuing their death spiral into their stellar furnaces? The future of research into ultra-short period planets is incredibly exciting. On the ground, the next generation of extremely large telescopes is under construction. Giants like the aptly named Extremely Large Telescope will have mirrors over 30 meters in diameter. Other concepts envision starshades, enormous flower-shaped spacecraft that would fly in formation with a telescope, blocking out the light of a star so that we can take a direct picture of the planets orbiting it. The journey to understand these cosmic sprinters is really a journey to understand our own origins. Each discovery adds a piece to the grand puzzle of our place in the cosmos. The story is far from over. We will continue to build our telescopes, to refine our theories, and to look up at the sky with a sense of wonder. The ultra-short period planets are waiting, holding their secrets close, ready for the next chapter of exploration to begin.